let us have a look at some problems on diode models, in which I would like to start with the very first case as ideal diode. See the first question. Find the values of I and V in the circuit shown in given figure. Some circuit is given and in which they are asking us to find the current and voltage. Okay, how do we do this? As I mentioned earlier, ideal diode. First of all, if you look at the problem, nothing is mentioned about the diode. So by default, we can assume ideal diode. The first point is assume ideal diode. Next, what about the status of the diode? If you look at the two terminals, anode and cathode, cathode is going to the ground potential and anode is going towards 5 volts. So definitely anode is at higher voltage compared to cathode, hence the diode conducts. So diode conducts. Once the diode is on, as it is ideal diode, it acts as short circuit. So that what is the equivalent circuit? We can take the equivalent circuit like this. It is a 2.5 kilo ohms, 5 volts and the current I. What is V? V is just nothing but voltage across the diode. V is simply 0. What about the current I? I is equal to, it's like a regular network sound. So what do we get? Here it is 5 volts, here it is 0 volts. So 5 minus 0 by 2.5 kilo ohms, it gives us 2 milliampere. So what is the answer? Option A is correct. Current I is 2 milliampere and voltage V is equal to 0. A very basic level question it is. Next. Find the values of I and V in the circuit shown in given figure. Here also nothing is mentioned about the diode, hence we assume ideal diode. Look at the terminals of the diode. Anode is connected to ground now. And what about the cathode terminal? It is going to minus 5 volts. So even though anode is at ground potential, cathode is going to much negative potential and hence diode will conduct. Once the diode is on, it acts as short circuit as usual. So what is the equivalent circuit? Diode is acting as short circuit. Here instead of diode I am writing short circuit. And V is the voltage from anode to cathode and I is the current through the diode, of course. So what is V? If you take V is voltage across the diode, V is 0. And what about the current I? I is equal to, here 0 again minus of minus 5 by 2.5 kilo ohms. It gives us 2 milliamperes. The same answer we can see. That is 2 milliamperes and 0 volts. Okay, very simple thing. As I mentioned earlier, the various cases, anode is at higher voltage compared to cathode, right? Anode may be positive, anode and cathode may be at positive potentials, or anode is at positive, cathode may be at ground, and anode may be at ground, cathode is at much negative. All these combinations you can see in these problems. Next, third one. For the circuit below, using ideal diode, the values of V and voltage V and the current IR. See, here it is mentioned ideal diode. Okay, well and good. So, what about the status of the diode? See, the terminals anode and cathode. Anode is going to plus 3 volts, and okay, not exactly, it's connected to the positive supply, and cathode is connected to minus 3 volts. Definitely diode will conduct. Once the diode is on, the diode simply acts as short circuit. V is the voltage at this point with respect to ground actually. And what about the current I? Okay, first of all, what is V? V is equal to minus 3 volts. What is the voltage at this point? Anyway, it is short circuit, no? So, V is equal to minus 3 volts. And what about the current I? I is equal to 3 minus of minus 3 by 10k. It is equal to 0.6 milliamperes. So, V is minus 3 and I is 0.6 milliampere. Option A is correct. Very simple. Okay. If you have any doubt, you can just see the things like this. It is minus 3 means what does it mean? It's negative terminal and positive is going to ground. Here the voltage is mentioned as V means V is the voltage at this point with respect to ground. How much it is voltage at this point with respect to ground means minus 3 volts only. Okay, that's it. Question number 4. Find the values of I and V in the circuit shown in given figure. Again, assume ideal diodes, the very first point. Next, look at the terminals anode and cathode. Cathode is going to towards positive supply and anode is going to ground. So definitely anode is at lesser voltage compared to cathode. Diode does not conduct. So here as the diode is not conducting, diode simply acts as open circuit. V is the voltage across the diode from cathode to anode. Once the diode is open circuit, is there any scope for the current to flow through? No. The current is simply 0. And what about the voltage V? Cathode to anode voltage should be positive, then only diode is off. Okay, anyway, let us see that. If I take the loop equation, even we can take this loop equation. What we can write? 5 volts is equal to I into 2.5k plus V. So 5 volts in which the current I is simply 0. Means what is V? It is 5 volts. Cathode to anode, it looks like positive voltage. The reality is it is the voltage from cathode to anode of the diode. That's it. So what might be the answer? Current is 0, V is 5 volts. Option C is correct. That's it. Next. Find the values of I and V in the circuit shown in given figure. Again, assume ideal diode. What about the status of the diode? The cathode is going to ground and anode is going to minus 5 volts. Definitely anode is at a lesser voltage compared to cathode, hence the diode is off. Once the diode is off, it simply acts as open circuit. V is the voltage across the diode from cathode to anode. Please do observe this. And what about the current? There is no scope for the current to flow in the circuit. So current is simply 0. How do we get V? Again, we can take the loop equation here. If I take this loop equation, V plus I into 2.5K minus 5 is equal to 0. Anyway, I is 0 implies V is equal to 5 volts. That's it. So previous problem and this one are almost same. I is 0 and V is equal to 5 volts. So option C is correct. For the circuit shown in figure, the voltage VO is here also. Anyway, it is the question asked from previous gate papers. Okay. Here also, as nothing is mentioned about the diode, assume ideal diode. Okay. After that, what about the status of the diode? Anode and cathode terminals. So, if you observe this, it is to the right of anode and to the left of anode, we have 2 ohms resistors. Right. So, left of anode, it is 2 ohms, and finally, right, it is 4 volts is connected to the anode of the diode through 2 ohm resistor. That's better way to speak. So, next, to the right of the diode, anode is connected to minus 2 volts through another 2 ohm resistor. Okay. Then what about the diode status? Definitely the diode will conduct, because which one dominates? 4 volts will dominate compared to minus 2 volts. So definitely the diode is on, or diode conducts. Once the diode is on, it simply acts as short circuit. Four volts, 2 volts, 2 ohms, 2 ohms. And V output has polarities from bottom to top. Let me take this voltage as VA. So what is the relation between VA and V output? VA is equal to minus V output. That's it. We need to find what is VA. Okay. For finding VA, let us take the node equation. Node A, let me take this as node A. Or node X, anything we can write. Vx, we can write so. Not an issue. So KCL at node A. If we take so, VA minus 4 by 2 ohms plus VA by, here this is again 2 ohms, plus VA minus of minus 2 by 2 is equal to 0. So here 3VA is equal to 4 minus 2, it is 2. So VA is equal to 2 by 3 volts. Okay, so means voltage at this point with respect to ground, it is positive, right? No issues. Means anode of the diode is going towards a positive supply and the cathode is going to ground. So anode is at a higher voltage compared to cathode. Diode is on, everything is fine. What about V output? V output is equal to minus VA, and hence it is minus 2 by 3 volts. Or I can even write minus 0 6, 6, 7 like this. I can even write 6, 7 volts. So if you look at all the options, option D is possible. It's not 2, 1, minus 1, right? None of the above. That's it. A very simple question it is. Then the diode D used in the circuit below is ideal. The voltage drop VAB means voltage across the 1 kilo ohm resistor they are asking. 1 kilo ohm resistor is okay. How do we do this problem? See, here we can use the source transformation. 1 ohm resistor in series with in parallel with 5 kilo ohm, right? 1 ohm current source in parallel with 5 kilo ohm resistor. What we can write? Right, it is a 5 volts voltage source in series with 5 kilo ohm resistor. Let us write its equivalent circuit. 3 volts 1 kilo ohm diode, 5 volts 5 kilo, and they are asking us to find VAB. Look at the diode. What might be the status of the diode? Does the diode conduct? No. The anode of the diode is going to 3 volts and cathode is going to 5. Anode is at lesser voltage compared to cathode. Diode does not conduct. We can write. Means the diode simply acts as open circuit. So what is the equivalent circuit? 3 volts 1 kilo ohm, it is VAB, 5 volts and 5 kilo. Okay, is there any current that is possible through this 1 kilo ohm resistor? No, the current is simply 0 as the diode is off. Then what is voltage across the 1 kilo ohm resistor? It is I into 1K. As I is 0, it is simply 0 volts. That's it. VAB, it is 0. It was asked in instrumentation paper 2016. Okay, like this we can solve. Again, look at question number 8. In the circuit shown in the given figure, is the current ID through ideal diode. Zero cut-in and forward resistance. Okay, zero cut-in voltage means it's an ideal diode. And zero forward resistance, that is also possible for ideal diode. What is the current through the diode they are asking. Again here also source transformation. Just if you look at this part, we can write it's a Thevenin's equivalent circuit, right? And here we can make use of source transformation. Okay, Thevenin's equivalent. Here I'm using source transformation. So what is its Thevenin's equivalent? Thevenin's equivalent voltage is 5 volts. Thevenin's equivalent resistance is 2 ohms. I need not write all those additional steps. Okay, VTH, Thevenin's equivalent voltage, 10 into 4 by 4 plus 4, it is 5 volts. And R Thevenin's is equal to 4 ohm parallel with 4, it is 2 ohms. So 5 volts in series with the 2 ohms. Next, diode. Next one, what about the voltage source polarity top to bottom? And here 1 ohm resistor and voltage is 2 volts. Now what happens to the diode? Okay, they are asking the current through the diode. Okay, yes. Look at the status of the diode. Anode is going to 5 volts and cathode is going towards 2 volts. Anode is at higher voltage compared to cathode and hence the diode conducts. The current I suffix D. It is 5 minus 2 by 2 ohms plus 1 ohm. Anyway, the diode will conduct, it acts as short circuit. So 2 plus 1, it is 1 ampere. Option C is correct. Single diode, that's it. These are all very, very simple questions. Okay, like this we can do.